Good question, a subscriber, or at least the viewer, I should say. I don't know if he subscribed or if isn't, feel free to subscribe. Click the like button or hit that like button, and like as with anybody else, comment down below if you have any questions, comments, or suggestions. The question was regarding the starters. So I did on Facebook, I didn't do on YouTube, the disassembly and repair. And here's the two little clips, the little U-clips they made out of the license plate sheet metal. See down there, and just bent that so that would hold these brushes apart when I slid on the base of the starter over the shaft there. Well, in regards to where I found the issue of the three starters, these L head opposed twin Briggs, the issue I found was, I relate it to like a battery. It's not exactly the same, but you figure volts has a relationship to amps and resistance. It's called Ohm's law, and you can go online and read about those different relationships. Well, like a battery, a DC battery, you can charge it and it'll show like it's a full charge, but the problem is when you put a load onto it, there's so much resistance, there's not enough current able to be produced, so it drains really quick, and it really can't power anything. It's not the best relationship, but I don't know. I might be wrong. I'm a chemist. My background's chemistry and computer information systems, not really electronics. But it's kind of the idea I'm thinking here, where if you have too much resistance in these windings, you're not going to be able to have enough current. So your voltage, you apply a voltage, I should say power. You're not going to have enough power. I think that's the best way to say it. That's probably better. So you apply a battery, and that's a good battery. It's plenty of current. Voltage is up, right? It's charged. It'll spin these starters, but when you apply a load to the starter to actually start it, like the flywheel with the engine, there's too much resistance. There's not enough power translated through to rotate the starter. So this is an example. So I have a multimeter here, and I have it set to ohms. Now I've already went ahead and tested these, and you can see I marked X's where I found these bad commutators. These are the commutators, individual commutators, and they're related to the windings. So I won't get too complicated here because I'll confuse myself and I don't want to confuse anybody else. But basically, you take your multimeter. This is a DMM, I call it a digital multimeter, and you put it on the resistance at ohms value, and then you measure. You touch two of these together and see what your values are. You see, I'm getting 84. That's way too high for those two. Let's see these ones. Try to do this one-handed. Yeah, 85. That's way too high. Touch these two. Okay, 2.2. That's getting better. Still not good. Let's just pick two more. All right, so that's a good one. That one you're getting down to 0.5. So this one's got a few good ones. Yeah, 8.9. That's too high. So this is my worst one. This one's bad. Now this one, interestingly, and I'm pretty sure, I thought there was an open one on this one, but I'm not finding it. I thought I had X'd the open ones. Maybe you got to go around and test them all. Yeah, that one's 1.5. So that's all kind of wonky. Now this one check out that. That's pretty much open. I mean, that's a lot. That's pretty. It won't test continuous. I guess that's why I inscribed a big X on it. Now these other ones, though, I think they all test good. Yeah, see, that's what you want. You want really low resistance. So I go around and keep testing too, and they're really low. So they're all, move over to the next one. And yeah, so this one, somewhere, there could be like a cold joint. So, see how this wire looks a little wonky there too, compared to these ones? Something up with the wiring in there. There's not like wire jammed in. There could be a break, like a microscopic crack somewhere. It might not be in the windings where, you can't get into. It's called potted down here, like epoxied. Technically you can rewind these, but most don't. But you can't actually rewind these, and that's probably something I'm going to try. Notice this design, they didn't have as much epoxy in there. It's easier to clean out potentially. This one, well, it's just jam-packed, which might be better so it doesn't break, but I don't know. I might be wrong there too. So yeah, you don't see that in the U.S. as much. Maybe some companies do. I see it in videos in Asia and Indonesia, but that's basically what you really need to test. You get in continuity with all these when you go around and test them, and then which ones, if you're not, have high resistance. You want really low resistance, like we showed here, 0.02 or 0.2, not 1 or above. One might be okay. One's probably all right, but when you start getting into 2, 3, you're gonna have issues. It's gonna make a difference if you do that math with volts, amps, and resistance, the relationship. So okay, well, that's about all I can think of. Be safe, take care, and learn something new. Thanks much, and have a good one. God bless.